Okay, so the last section in Chapter 1 is Section 1.7, Linear Inequalities. Up to this point, we've been pretty much doing equations, and equations have for answers a single number, or in the case of like polynomial equations, 2 or 3 numbers, but not a big set or range of numbers. When we solve linear inequalities, what we're going to get for answers most of the time is a set of numbers or an interval of numbers. And the way that is expressed as we go into higher level mathematics, the way we express sets of numbers or inequalities sometimes is with interval notation. So the first thing we will discuss is interval notation. Now there's some basic rules of interval notation. Number 1, to include a number in a set, we're going to use square brackets. You're going to use square brackets whenever the inequality involves or equal to. To exclude a number from a set, you're going to use parentheses. The smaller number must always be on the left. Now notice I put number in quotation marks because sometimes we'll be using the symbols infinity and negative infinity, and those aren't numbers. Negative infinity is the idea of decreasing without bound. There's nothing smaller than negative infinity. So when we're doing an interval and negative infinity is involved, it's going to be on the left. To indicate all numbers greater than a given number, we'll use infinity. To indicate all numbers less than a given number, we'll use negative infinity. And then infinity and negative infinity must always have parentheses. The square bracket in interval notation means you're going to come up to this number and use it and include it. It's like a hard concrete stop sign. Come up to this number and use it. That's what a square bracket is. The concepts of infinity and negative infinity are getting bigger without bound, getting smaller without bound. And so you can't stop that process, so you can't put a square bracket on those guys. Okay, what we're going to try to do next now is to understand the equivalency of all these things. And so the point here is to this chart is that this is called set builder notation. You can really look at just the inequality, that the inequality, the interval, and the graph all mean the same set of numbers. So in set builder notation, and the way you would read that is the set of all x such that x is greater than 1. But let's just really emphasize the x is greater than 1. The equivalent interval is the open interval from 1 to infinity, and then the graph would look something like that. Now I'm not going to do great guns on the graph, just anything that seems reasonable, but notice a parenthesis, and then an arrow pointing the numbers greater than 1. And the point to this chart here is that all these numbers, all these notations express the same set. The above describes the set of numbers bigger than 1 than not including 1. But notice there is not the or equal to, so I have parentheses, and then greater than 1 forever is infinity. So 1, the inequality x greater than 1 is the same as the open interval 1 to infinity. Now the only difference here is I'm going to put an or equal to. So then that means all numbers bigger than 1, including the 1. And then the difference on the interval notation, now that it has the or equal to, is the square bracket. Or equal to goes with square bracket. Then to indicate bigger than 1 forever, the infinity. And then the only difference in the graph, the square bracket. Continuing on with more of these. We just got lots of them. So now we're going to flip it around. Less than 1, x less than 1, and again if you wanted to read that whole notation, that would be the set of all x such that x is less than 1. That's what they refer to as set builder notation. Verbally, that means the set of all numbers less than 1 but not including 1. And then the way we're going to describe an interval notation less than forever is the symbol negative infinity. And so we have the interval from negative infinity to 1 with parentheses because I do not have the or equal to. And there would be a graph, parentheses at the 1, and then an arrow pointing the numbers less than 1. Then changing it just a little bit, putting the or equal to on there. So now we're including 1, and then or equal to always goes with a square bracket. So we'd have the interval from -1 to infinity with a square bracket on the 1, and then the difference in the graph, just the square bracket. And now notice, negative infinity is certainly smaller than 1, and it is on the left. The smaller, in the interval notation, the smaller number is always on the left. And the same thing up here. Between 1 and infinity, 1 is certainly smaller, and it is on the left. Okay, compound inequality. The set of all x such that -2 is less than or equal to x is less than or equal to 3. Verbally, the above describes the set of all numbers between -2 and 3, including both negative and 2 and 3. The interval notation there, we'd say that's the closed interval from -2 to 3. I don't really care if you get the verbiage right about being a closed interval. But since both of them have or equal to's, I have square brackets on both of them, and then the graph would have square brackets on both the -2 and the 3, and then a line in between them. And then we'll start messing around with this guy. This time I take away the or equal to. So verbally it means the set of all numbers between -2 and 3, excluding both -2 and 3. In the interval notation, same idea, but now parentheses. Because I do not have the or equal to, I use parentheses. The or equal to goes with square brackets. And notice the smaller numbers on the left. And there would be the graph. Now we do need to get used to a little difference here. In other applications, when we start talking about graphing lines, this might look like a point. And so you have to keep what application you're working with in mind. Here we're working with intervals, so this is interval notation. Later on in life, when we're graphing things, this could be a point. So you do have to keep in mind what you're working on to interpret the symbols correctly. Now we're going to put an or equal to on there with the 3. Then the only difference is a square bracket on the 3 and a square bracket on the graph. And then this time, I'm going to put the or equal to with the -2. So the only difference in the interval notation now, a square bracket on the -2 and a square bracket on the graph. And it's interval notation how we're going to be expressing most of our answers. Now, practicing with this a little bit, fill in each blank so the resulting statement is true. The interval notation, the interval from 7 to 10, so we'll just say square bracket on the 7, parenthesis on 10, represents the set of real numbers between 7 and 10, including the 7 because it has a square bracket, and excluding the 10. The interval -4 to infinity represents the numbers and here we just write greater than 4, -4. But not or equal to. It does not have the parentheses, so it's not or equal to. Example 2. In each of the following, express the given interval in set notation and then graph the interval on a number line. So set notation is this, the set of all x such that, and now you just have to write the corresponding inequality. So this has 2 numbers, so it's going to be a compound inequality. So -6 less than or equal to, because the -6 has a square bracket, less than or equal to x less than 5. There's the set builder notation. And then, we're looking for a graph. We don't need anything really wonderful. There's my number line. And then so we can see it, a square bracket on the -6, parenthesis on the 5, and then a line in between. But the or equal to, that goes with the square bracket. Some more, the interval from -infinity to 3. The negative infinity is the way we indicate less than forever. So it's going to be the set of all x such that x is less than the square bracket or equal to -3. The negative infinity gives the less than, square bracket, for the or equal to. And then graph, there's -3, square bracket, and an arrow pointing to the numbers less than -3. Same idea here. This is going to be the set of all x such that x is greater than 4. The infinity gives me the greater than. And then I do not have the or equal to, so no square bracket. Graph, there's 4, parenthesis, and then an arrow pointing to the numbers greater than 4. And lastly, the closed interval 0 to 8. So that's just a scribble there. That's going to be a set of all x such that 0 is less than or equal to x, less than or equal to 8. They both have square brackets. Square brackets is the or equal to. And graph-wise, so there's 0, there's 8. Square brackets on both of them, and then a line in between. And so all we're trying to get here is the relationship between the inequalities, the intervals, and the graphs, that they all mean the same set of numbers. And we're going to use this interval notation to express our answers for inequalities. So the first type of inequalities we're going to be doing are linear inequalities, solving linear inequalities. Linear inequalities are solved as you would linear equations, but with one difference. If you ever multiply or divide both sides of an inequality by a negative number, you must reverse the direction of the inequality symbol. There's the one huge difference, but you got to remember that one huge difference. If you ever multiply or divide both sides of an inequality by a negative number, you must reverse the direction in the inequality symbol. Otherwise, all the steps to solving a linear inequality are going to be the same as the steps to solving a linear equation. You just have to remember that one difference. And we will start practicing problems on the next video.